Bisectors of Triangles. Our objective is to apply properties of perpendicular and angled bisectors of triangles. Who uses this? An event planner can use perpendicular bisectors of triangles to find the best location for a fireworks display. Let's look at some vocabulary first. Concurrent is when three or more lines intersect at one point. The point of concurrency is that point where all those lines intersect. The circumcenter of a triangle is the point of concurrency of the three perpendicular bisectors of a triangle. So circumcenter, perpendicular bisectors. They go together. Circumscribed. Every vertex of the polygon lies on the circle. Incenter of a triangle is the point of concurrency of the three angle bisectors of a triangle. So incenter deals with angle bisectors. Inscribed. A circle inscribed in a polygon intersects each line that contains a side of the polygon at exactly one point. Let's look at the circumcenter theorem. The circumcenter of a triangle is equidistant from the vertices of the triangle. So your blue lines, so AP, BP, CP, they're all the same measure. To find the circumcenter, you find the middle of each side and then go perpendicular from that side. There's your circumcenter. Once you have the circumcenter, to each vertice will be the same length. The circumcenter can be inside, outside, or on the triangle. If you have an acute triangle, it's going to be inside the triangle somewhere. If you have an obtuse triangle, it's going to be outside the triangle. And if you have a right triangle, it will actually sit right on the triangle's hypotenuse. Let's use properties of perpendicular bisectors. So we have KZ, LZ, and MZ are the perpendicular bisectors. So that tells you that those three lines where they meet is going to be your circumcenter. We want to find the measure of HZ. So we know that each of these are the perpendicular bisectors, making this our circumcenter. Therefore, from this point to every vertice will be the exact same length. So if GZ is 19.9, HZ will also be 19.9. Alright, so now let's try practicing finding the circumcenter of a triangle. Find the circumcenter of triangle RSO when it has the vertices R is -6, 0, S is 0, 4, and O is 0, 0. So our first step is to draw the triangle as you see here. Once you have the triangle drawn, you want to find the middle of each of your sides. So the middle of RO is going to be right here. And the middle of SO is going to be here. And then you want to travel the perpendicular bisectors of those. You can find the third one as like a double check. So if we want, we can find the midpoint of RS. So halfway between would be -3 and then 2. So -3, 2 would be the midpoint of that side. And now we want to run perpendicular to each of our sides. So we want to go perpendicular to RO, which is going to be a straight up and down line. And then we want to go perpendicular to SO, and it's perpendicular to the line that you just put the midpoint at, not some other random side. It's this line right here. So now you want to make sure you go perpendicular to this line. No other line but this one. So you're going to go through and you're going to just make yourself a line that goes horizontal. A ruler is probably a better tool than to freehand. So for those of you that are drawing this in your notes, I would definitely use a ruler when drawing these out. And then if you wanted to, you can go perpendicular to this side as well. And to do so, you would want your slope. So I'm going to do this one in red because this is kind of like our double check one. You should always do the easier ones first. So if something is horizontal, just go vertical with it. If something's vertical, go horizontal with it. And then the other one, like the ones that are diagonal, those are the ones you have to do a little bit of work for. So our rise is 1, 2, 3, 4. So we have 4 over 1, 2, 3, 4, 5, 6. So we can reduce this to 2/3. And if we want the perpendicular, because we don't want to just go parallel to this, we want it to go perpendicular from this point. We want to go perpendicular, so therefore opposite reciprocal. So you're going to go down 3, 1, 2, 3, and over 1, 2. So your line would come through here. Now, where all three intersect, that is your circumcenter. So your circumcenter is right there. Let's look at the incenter theorem. The incenter of a triangle is equidistant from the sides of the triangle. So it's almost a little bit backwards to the circumcenter theorem. It's saying that each of these distances here, the px, the pz, and the py, each of those is going to be congruent. But to find the incenter, you're going to cut each angle. So each vertice of the triangle, you're going to cut it in half. You're going to bisect each angle. And wherever those 3 points meet, once you have that point, that's your incenter. When you have your incenter, that means that py, pz, and px are the same length. What's really cool about the incenter is no matter whether you have an acute, an obtuse, or a right triangle, it is always in the center. It's in the center, in center. Always in the center. So let's practice using this one. So we have JV and KV are angle bisectors of triangle JKL. So you know that this angle is going to be equivalent to this one. This angle here is going to be equivalent to this one here. Okay? So, with that being said, we want to find the distance from V to KL. So from point V to line KL. Well, you always go from a point to a line segment or line in its most direct path. If you recall from a previous lesson, the most direct path is to go to it perpendicularly. It's a straight path. So we're looking for this distance right here. Because it's going to meet it perpendicularly, so there's one distance, V to line KL. Well, if each angle is bisected, that means that from V to every side length is going to be the exact same measure. So if from V to W is 7.3, V to, we'll call this X, V to X will be 7.3 as well. Now we're getting a little bit trickier. we have the measure of angle VKL. So VKL. We're looking for the measure of this angle right here. Well, if this one's 19, we know this one's 19. And since we know that angle JLK is 106, we can put our 19, our 106 together. And we know that a triangle has to be 180 degrees. So we can use that fact to try to figure the rest of it out. Well, let's start with WJL. We know that altogether, this angle here, if we add 19 and 19 together, that's going to give us 38 degrees. So then we can do 180 minus the quantity 38 plus 106, which gives us 36 degrees. And it wanted to know the measure of angle VKL. So we're simply going to divide 36 by 2, because we want half of that since both of these are going to be the same size. So we're going to divide by 2, which then brings us to 18 degrees. The biggest mistake people make when trying to find the angle measures is they forget to go one more step. A lot of times people will stop and go, oh, we've got 36 degrees. Make sure you're answering the question being asked. It wasn't asking about WKL, it was asking about VKL, which is half of that 36. And that concludes our lesson on bisectors of triangles.